Hello folks, and welcome to this video, which is all about the relationship between two numerical concepts, the frequency and the period. Now, whenever we're using the term frequency, it can be used in physics and non-physics contexts. And really the idea of frequency is about how often something happens. Now, in physics, we have a specific definition that the frequency is to do with the number of complete cycles of a repeating process every second. Now notice that time frame there is very specific. We're talking per second. So any repeating process could be a pendulum, could be a mass on a spring, could be a wave, can have a frequency. And when we measure that frequency in physics, we're talking about the number of complete cycles every second. Now when we measure frequency, we express it in hertz. That's given the symbol Hz, and that might be a new symbol to you. This is a named unit and it has a very specific meaning, which we'll see in a second. To see what that kind of means, we need to know the equation. And the equation to calculate frequency is simply 1 divided by t. That's capital T, where capital T is the period. As a reminder, the period is the time taken for a cycle to be complete, from beginning to the end of the cycle. And when we want to calculate the frequency, we simply calculate the reciprocal of that, 1 divided by the period. Now it's helpful to kind of look at this equation and interpret what we mean by hertz. Well, if we've got 1 divided by seconds, then 1 hertz is simply 1 per second. And I put that in sort of inverted commas because it's quite a weird unit. It means that 1 oscillation or 1 cycle, 1 vibration, 1 cycle per second happens when the frequency is 1 hertz. If the frequency is 5 hertz, we have 5 cycles, 5 waves per second, and so on. So hertz is just really a fancy way of saying per second. It may just be simply that this is named unit, named after a person, hertz. However, it may also be that this is slightly difficult to understand, the idea of per second, and so hence we give it a named unit, and that kind of clears things up a little bit. Okay, now what we're going to see is an example of a frequency in real life. Now here's a label from a single-phase induction motor. No idea what that is, I'll be honest with you. However, it's important. There's a bunch of things on there that you may have met. Now you can see, for example, power. You can see a potential difference, and you can see a current, and somewhere on there there's a frequency. So why not take a second to pause the video and try and find that frequency? Hopefully you've seen it there. It's 50 hertz. And what this means is this single-phase induction motor has been designed to work with a signal, with an electrical signal, which has a frequency of 50 hertz. And you might be asked to, for example, calculate the period of that signal. Well, if frequency is 1 over t, then t is going to be 1 over f. We know the frequency here, 50 hertz, then the period is 1 over 50, 0.02 seconds. You can see that as one goes up, the other one goes down. So we've got a bigger frequency, smaller period. Now, what does this really mean? Well, you should be aware that in our walls, our electricity is sent to our homes in what we call an alternating signal. And that's what you can see on the screen. This is an oscilloscope trace showing the signal that's in your wall. And what you can see is that electricity, instead of being in one direction, changes its direction. And it changes its direction with a frequency of 50 hertz. That's quite incredible. 50 times every second, this signal will change its sign. Plus, minus, plus, minus, plus, minus. Now, to give you a reference point, we often think of the heartbeat as being a cyclic process, and that happens around about once, maybe 1.2 hertz. So there are 1.2 beats, cycles of the heartbeat in 1 second. The electricity in your walls changes directions 50 times a second. Now, I can't even really fathom what it's like to do 50 of anything every second, certainly not changing direction. Now, what you're going to see in later units, when we talk about light and, for example, sound waves, you're going to see that the frequencies actually get incredibly high. We start talking about kilohertz, thousands of times per second, maybe even megahertz, gigahertz, as much as tera. Okay, so we're going really high frequencies in some cases. Sometimes when we calculate these things, you've got to expect to see high numbers. But in the case of everyday things, it may be a bit lower. Okay, but we'll save that for another time. As ever, please, if you've got any questions, let me know. If not, then crack on to the next task. Thank you for watching.